All right. So last but not least, we'll get to Josh Trotta. Ah, here he is. I was looking for you.
Yeah,
so Josh is the Senior Director of Business Development at Thermo Fisher and will tell us about their NDR, XDR work.
Yeah, thanks, Claudia. So I kept it to one slide, so maybe I get points for hopefully 3 minutes. But as we look at this, it's interesting just hearing some of the discussions. I come from a company that represents one of those next-gen sequencing things that people have been talking about. And then we also are on the side of the Sanger sequencing and the qPCR technologies. And there's a lot of discussions kind of just internally on what you actually do with this. So what I'm actually going to talk about in the slide that I have here is there's this gap in between. It's to say you want the technology associated with next-gen sequencing, but you want it at the cost associated with like a qPCR or even like an endpoint kind of PCR piece. So there's a balance in between of where do we fit. So I'm actually not talking about the point of care market. I'm actually talking. Did I get it? Right. There we go. Not talking about point of care, but actually talking more about the centralized testing facility. And what I'm talking about here is, can you actually give a better answer in the centralized testing facility to help in actually reducing the burden of drug resistance because you have a better answer? And so really the focus here is to say what we've endeavored to do is to start with sputum samples. So we have different technologies on the sample prep technology. Within Thermo Fisher, we're a big company that has all kinds of stuff. And part of my job is to take this stuff and to make it into usable solutions that actually resonate for answering problems in the marketplace. So taking some of our sample prep solutions, going directly from sputum down into content. And so I kind of highlight here is that we can cover all of these markers, which are the primary ones that are covered in first line and second line treatments. And you can see here is that you can scale this depending on what kind of content you want to screen. So with this particular platform, we're using an open array technology, which is 33 nanoliter materials, so it allows your volumes to be very small. And it's also what I would call spatial multiplexing. So challenge with multiplexing is you build something together and then somebody's like, well, what about this new drug that we just had? Or, hey, we just looked at the sequencing database and this thing looks like it's a lot more important than that. Trying to decouple the multiplex can be very challenging. And with a spatial multiplexing, you can actually easily move things in and out to be relevant, which can be important, I think, from areas where you look at maybe there's regional nuances in Asia versus India versus South Africa, and if you have nuances that you want to build out, that allows you to do that. So we've kind of built this out, the concept. We've done some work in just looking at the sequencing to design these specific TACMAN assays to this content, and you can kind of get an idea of, depending on how many markers you want, it can really impact your costs. So you can get down to as low as $7 US per sample, and you can screen up to 1,200 people or 1,100 people a day on one instrument. So time to results about 5 hours. We're actually under development of just looking at both kind of internal or the controls components, and really we're targeting centralized reference labs with a solution like this. So I'll stop there.
Thank you very much, Josh. Any quick clarifying question for Josh? Nope. All right. Good. Then I'll ask Michael to come up to the stage again as well. And I think we've heard a good overview over various exciting technologies at various stages of the development. So now I'll ask Madhu to come up and challenge the panels here with some questions about all of the steps from product concept to implementation. Thank you, Madhu.